All right, good morning, Elch2 Extended. I hope you guys had a good weekend. Last week of the semester here. But what we want to do is today we're going to do 6.4. It's more modeling with polynomial data. But before you do this lesson, unless you're watching this early before your live class, make sure, because today's live session, make sure you log in, because at the beginning of your live class, if you're in my class or Mr. Myers, we will be doing course selections for next year. Advisor advisee is right around the corner, and all your homeroom teachers need these projected classes to help you make your schedule for next year. So make sure you get to your live session to complete this. It's going to be in a Google form online, and Mr. Myers or myself are going to walk you through that and talk a little bit about what your choices for next year are. Tomorrow is going to be an online formative, and Wednesday is all work day. Hopefully you have been working on that pink review packet prior to Wednesday. You should have picked it up on Thursday or Friday last week, and we'll be reviewing that whole day. We will have our chats open that whole day. If you have questions, log in. And questions are actually, they're going to be a little bit too late on Thursday, because Thursday is the day you will be taking that exam, okay? And remember, that's 10% of your overall grade, so that would not be a very intelligent move to not go take your or to take your semester exam, okay? So again, what we're doing is we're modeling polynomial data, again, using regression equations. So fire up Desmos. And here we go, okay? So what we're going to do is we're going to do one example, then you can do your homework. And the example we're doing is inflation has influenced the price of a movie ticket over the years. The first movie theater opened in the year 1900, and they charged 5 cents a ticket. That's pretty cheap. Wish I could have seen a movie for 5 cents, but I'm not quite that old. Okay, the data provided shows how the average price of a movie ticket has increased over the years. Now, what you're going to have to do is you're going to have to go plot this table into some data. Now, my years are going to be my x's, and my average price are going to be my y's, obviously. But we don't want to do these points as 1900, comma 0.05, okay? Anytime you look at time-stamped data like this, it's always going to say somewhere in the directions. And what we want to do, we want to let x equals 0, we want that to represent the year 1900. Okay, so when we type our data in, and this actually makes it easier to use our regression equation too, makes numbers nicer. So 1900 is going to be put in as 0, comma 0.05. 1948, well, that's 48 years past 1900, 58 years past 1900. Now notice when I jump to the 2003, I know you guys are all very intelligent, but that's 103 years past or since 1900. So what I'd like you to do is hit pause, go make your scatter plot, and based off of that scatter plot, we are going to determine a regression equation that best models the data. Okay, so go make that little bugger. Okay, so hopefully you got your data put in here. And so there's my points. My window might be a little bit different than yours, but what I did is I went from the year 0, I went all the way out to the year 250. I guess I kind of previewed what they want me to do with this, and I know I'm going to be using whatever equation I'm going to do to estimate the cost of a ticket out to the year 2100. So I got to be out till 200 at least. And I can see from the year 1900 to 2009, I can see it went up to 750. So I just went up to 50 with my window, and it kind of changes your scatter plot a little bit. But as I'm looking at this scatter plot, it really does not look like a linear is going to fit me well. But remember here, we want the best model for us this year is as soon as, not real numbers squared, I did it again, we are looking for our best model as soon as r squared is greater than or equal to 0.97. We don't want, if we have one that models at 0.97, we don't want the one that models 0.99. We want the easiest one that we can use in this class right now. So why don't you go find that model? Okay, so what I did was I typed in 2 regression models, and like I said, it didn't look like that linear model was going to fit too well. And I say that because when I look at this here, I can see my R squared value is not at least what I want it to be, but the R squared value on my quadratic it's 0.993, so that's all good. That's what I want. So what I'm going to do is, nice thing with Desmos is I can just crash that linear one off. So I'm looking at my quadratic regression. And also notice that A, B, and C, I can't round A to 2 decimal places because then I wouldn't have an A. So I'm going to have to stretch this one out to 3 decimal places. And if I'm doing one of them to 3 decimal places, I sure by gum am going to do them all to 3 decimal places. So my regression function is going to be, I can call it f of x, and that's going to equal negative 0.001x squared minus b is negative 0.054x, and c is plus 0.130. You know, that last 0 really doesn't matter if you put that one on there. But I also know r squared is 0.993, meaning this is a pretty good model for our data here. So now what we're going to do is we're going to use that model, okay? And we want to use that model, use your regression equation to predict when the average price of a movie will reach $15. Well, what we're going to do, because here's my average price, that's a y. What I want to do is I want to graph y equals 15, and I want to find the intersection of that line and my regression equation. So I'm going to pull it back up. I'm going to come up here. I'm going to add myself a little expression, and I want y equals 15. And I can, it brings it right up there for me. There's my y equals 15. I want that point right there. And I can see, hey, there's the $15 ticket. This is when it's happening. And it's happening at 144.367. Well, that's the year 144.367. So what I'm going to do is I'm going to come back here and I say y equals 15 when x equals 144.367. So that would be during the year. Now I have to add 144 to my 1900. Well, what does that do? That takes me to the year during the year 2044. Okay? Explain your reasoning. Well, what do? We graphed the regression equation, we graphed the line y equals 15, and we found their point of intersection. That's all we did. Okay? Now the second thing we're going to do here is we're going to use this regression equation to predict cost of a movie during or in the year 2021. Well, remember, my years are x's. So I want to find the intersection of my regression equation and the year x equals, 1900 is year 0. So this would be 200 years past 1900. So all I'll do is I'll come back to my regression, and I'm going to come up here and I can change this one, or I can add a new one. I'm just going to get rid of this one, and I'm going to say x equals 200 this time, and I'm going to find this point of intersection right there, and I can see at 200, it's 32.827. Well, wait a minute now. Okay, so if I came down here and I answered this question as 32.287, 0.827, sorry, right? Let me make sure I did that right. 32.827. So 32.827. Well, that really doesn't make any sense in terms of dollars, does it? Money is always unconditionally rounded to 2, so that 7 is going to make the 2 round up to a 3. So the cost of the ticket should be roughly $32.83. Okay, so explain your reasoning. Again, we graphed x equals 200, and we found the intersection of that line with our prediction, with our regression model, and that intersection should be our prediction. Okay, so hopefully this all makes sense. You got a couple homework problems to do in there. Bottom line, if they're time sensitive, we usually want to rename that, letting x equals 0 represent a beginning year, okay? And yes, I could predict before the year 1900 if I wanted to, but in this case I wouldn't because there weren't movie theaters. But in a different application, if I had to predict the year 1890, well, x would be -10 then, and I could do a pre-prediction on it. Just got to, use a little logic. So from here on out, it's your homework for the rest of the day. If you missed your live session, you better reach out to Mr. Myers or myself, whomever is your grading teacher, because you have to get your course selection done. All right? Have a good one. Good night.